Gravity and free fall. There are certain aspects that will change the force of gravity. The first aspect is the distance between objects. If you take two objects that are close together, like the pen and the marker, they're going to have a stronger force of gravity between the two of them. Yes, they actually do have a force of gravity, but it's very small. If I put them further apart, then those two objects will have less of a force, a gravitational force between them. Closer, stronger force. Further distance, weaker force. What about the mass of the object? If I have a large object, like a large heavy object like this candle, okay? This candle is going to have a greater force of gravity than, say, the highlighter, right? Because it has a greater mass. If it has a greater mass, then it will have a stronger pull on all the objects around it. So gravitational attraction between all objects is a basic matter. It's a basic property of all matter. So think about that. Something as small as your fingernail actually has the property of gravity. You don't realize it because it's so small and the gravitational attraction is extremely small, so we wouldn't normally think of it as having a gravitational attraction, but it is a property of all matter. So why do objects in the universe not just come together in a clump? Why don't they all just attract one another and just kind of collide or implode on one another? The force of gravity is small on small objects is not great enough to overcome friction. So simply put, objects don't come together because they're being held apart by friction. The force of gravity for large objects like stars is also very weak because of the great distances between them. So a star in the other solar system doesn't pull on the Earth like the sun does because the sun is much closer. It has a smaller distance between the Earth and the sun versus the Earth and the star, which has a large distance between them. Newton studied gravity and came up with an equation for the force of gravity based on three variables. The variables are the masses of the two objects and the distance between the centers of the object's masses. So again, he says three variables here. The first two variables are the masses of the two objects. Then the last or the third variable is the distance between the center of the object's mass. So why are we referring to the center of the object's mass? Think of it this way. If you are on the Earth and you are really close to the center of the Earth is actually pulling on you with a greater force of gravity. If you go to the top of Mount Everest, technically it is pulling on you with less of a force of gravity, although you probably would never be able to feel that difference. It does pull on with less of a force of gravity, but the change is very small. Okay, this is the law of universal gravitation. F stands for force of gravity, so that's the force that the gravity's pulling of an object pulling on another. G, capital G, is a constant. That's not a variable, that's just a number. Capital M and small m are just ways to signify two masses. It could be M1 and M2, but M stands for mass of one object and then another M for the mass of the other object. So you can use a capital and a lowercase. You could use M1 and M2. It's the same formula, and you may see that somewhere on the internet, but it's just saying mass of one object times, they're right next to each other, the mass of another object, divided by r squared. R stands for the distance between the center of the two masses. So r, if this were the mass of the moon and this were the mass of the earth, r would be the distance from the center of the earth to the distance of the center of the moon. All right, so you can copy that down. Force of gravity, of course, gravity is in newtons. Gravitational constant, we'll talk about that in a minute. Mass of, it could be the larger object, if you want to put that first, the smaller object second. The distance between the centers of mass. Newton could not use the equation because he didn't know the value for G. He didn't know the gravitational constant, but he knew that the force of gravity was still related to the mass of each object and the distance between them. We have calculated its value. Scientists have calculated its value to be 6.67 times 10 to the negative 11th. Okay, just focus on the number. The number is very small. Do you see the 10 to the negative 11th? That means we take this decimal, we go 0.00000000067 or 667, right? Because we're going to put the decimal, move it to the left, 11 places, all right? And for now, you can ignore the units, but just notice there's newtons for force, there's M, not even sure what that is, and then that's divided by kilograms squared. Okay, oh, meters is distance, sorry. The units are necessary so that the answer is in newtons. So these units just get everything to cancel out nice and neatly. The small size of the number shows that gravity is a very weak force. Makes sense, right? Gravity is a weak force because you need a large mass and a pretty close distance to feel that force. What does this equation tell us? The force of gravity is directly proportional to each mass. So if the mass of either object increases, if I make this number bigger or this number bigger, what's going to happen to this number? This number, the force of gravity, will also increase, so that makes it directly proportional. The force of gravity is inversely proportional to the distance squared. So if we make objects further apart, okay, then this number will go down. Well, how much will it go down by? Well, if we double the distance, then this number will go down by 1/4. If we double the distance, this number goes down by 1/4 because 2 squared is 4. If we double either of the masses, then we'll double the force. So let's say that again. If we double the distance, then the force goes down by a 1/4. It'll be 1/4 the force, 1/4 of the force. If we double either of the masses, the force will double. I think, yeah, we're going to go over some sample problems in the next video. So you can go ahead and answer the questions, and then we will work on practice problems next time.